So today we are going to talk about rate of reaction. Your goal is I can explain what factors play a role in speeding up or slowing down the rate of reaction. So what is the rate of reaction? Here's the different things we're going to focus on throughout this unit. Remember, you only have to write things down if it is underlined or if it has been highlighted red. So what does rate of reaction mean? So that's the speed of different chemical reactions, and that speed varies hugely. Some reactions are super fast, and some reactions are really slow. The speed of reaction is called the rate. So the rate of these reactions, first you have a rusting, which does not happen instantly. It takes hours, sometimes days, for rust to appear. So that would be a very slow rate. Baking, it takes a while, especially depending on what you're baking, but it doesn't take too terribly long. So that would be a fast to your kind of your middle ground rate. And then you have explosions, which happen pretty instantly depending on what's reacting, which would be very fast. So why are some reactions faster than others? Reactions take place when particles collide with a certain amount of energy. The minimum amount of energy needed for the particles to react is called the activation energy, and it is different for each of the reaction. The rate of reaction depends on two things. You do need to write these two things down. The frequency of collision between particles and the energy which particles collide. So, how much do they collide and how much energy do they have when they collide? If they collide with less energy, then they won't react as much or as fast. They'll just kind of bounce off each other more than anything. So anything that increases the number of successful collisions or speed up the reaction will affect the rate or will make the rate faster. So these, I know they're a different color. You don't have to necessarily highlight or underline these words. We'll talk about the definitions of them later. You just need to type out what's underlined. So some different factors if you increase the temperature or make it hotter. If you increase the concentration or you have more of it. If you increase the pressure, increase the surface area, or use a catalyst. And we'll talk about how each of those affect it throughout the next couple of slides. So reactions do not proceed at a steady rate. They start off at a certain speed and then they get slower and slower until they stop. So as the reaction progresses, the concentration of reactants decrease. Or basically, once things start reacting, then you're not going to have many reactants left because some of them have already turned into your products. So a reaction typically starts off really fast and then slows down as it finishes up or as the rest of the stuff reacts and turns into the products. So how does temperature affect the rate of particle collision? Well, if you think about it, you wake up, it is a cold winter day. At least me personally, that makes me want to wrap up in a blanket, get a good book, get some coffee, stay still, relax, kind of like this guy in the picture. And then if things are hot, that's when you're wanting to go out, you're wanting to do stuff, you have a lot of energy when it's warm outside. Well, particles kind of do the same thing. When it's really cold, it kind of slows down the rate of reaction. If it's warmer, it speeds up the rate of reaction. So the higher the temperature is, the faster the rate of the reaction. And the reason why that is particles have more energy at a higher temperature, which means they move faster, which means they'll collide more. So why are batteries more likely to run down more quickly in cold weather? Well, at low temperatures, the reaction that generates the current proceeds more slowly than at higher temperatures. So that means batteries are less likely to deliver enough current to meet demand when it is cold. So the reaction between sodium thiosulfate and hydrochloric acid produces sulfur. Sulfur is solid, and so it turns the solution cloudy. How can this fact be used to measure the effect of temperature? Make sure to delete that last little bit. So, for concentration, the higher the concentration of a dissolved reactant, the faster the rate of reaction. Why does it affect it? Well, if there's a higher concentration, there's going to be more there. If there's more there, then they're going to collide more. And if they collide more, then that means the reaction will happen faster. Surface area. So a low surface area, in this first picture, you see this big square. So most of that area is inside that square. Whereas if you were to cut that up, there's more of that square showing around, or that's on the surface. So since there's more surface for the particles to bounce off of, then they will react, or they will collide more, which means they'll react more. What are catalysts? So catalysts are substances or compounds that change the rate of reaction without being used up in the reaction. So they're just kind of like there to help push the reaction along, but they don't actually take part in it. It's kind of like that person who always starts fights, but they just whisper a little something and then back off and then see the fight happen without really being involved in it. Well, that's what a catalyst does. It just kind of gets it going. It gets it started. It pushes it to make it go faster without actually being involved. Okay, so here are the definitions from the last couple of pages that you need to know and the wording that you need to know. First is activation energy, which is the amount of energy needed to start a reaction. Next is a catalyst, or a substance that increases the rate of chemical reaction without being used up. Then you have your concentration, which is the number of molecules of a substance in a given volume. Then you have enzymes, which is a biological catalyst, or something that'll speed up the rate of reaction found naturally. And then a rate of reaction is the change of concentration over a certain period of time.